Assalamu alaikum students, welcome to Nust Entry Test series. This is your lecture number 2 and today we are going to discuss matrices. We will try to cover matrices in this video lecture. So when you talk about a matrix, this is basically information stored in the form of rows and columns enclosed in brackets in the form of digits, figures is called a matrix. Right? For example, if I write A as 2, 3, 5 and 6, B as a matrix 4, 6, 8 and 5, 1, 2, C is a matrix with 1, 4 and 6. So here we need to understand that these are known as rows. So this is my row 1 and row 2. For example, this is my column 1 and this is your column 2. Similarly, in matrix B, these three horizontal rows are there. So we can say row 1, row 2 and row 3, and these are vertically columns. So C1, C2 is representing column of a matrix. Similarly, it goes in this way. This is row 1 and these are columns. So C1 and it is C2 and it is C3. Okay, first of all in this chapter you should know what is order of a matrix. So for example, if I have a matrix A in which it is 2, 1, 3, 5, 6, 8. So if I name it, this is row 1, this is row 2. So this matrix has 2 rows and this is your column 1, it's column 2, it's column 3. So order of a matrix, order is equal to number of rows into number of columns. It is basically number of rows into number of columns. Usually we represent it as M and N. So number of rows are represented by M and number of rows are represented as column N. So for we can say that these are basically M into N, number of rows into number of columns. For example, in this matrix, order of this matrix is equal to 2 cross 3, right? Because I have 2 rows and 3 columns. Similarly, if we see here in this case, matrix A, it has 2 rows and 2 columns. Remember, this does not mean 4, okay? It's only a format of expressing that these are 2 into 2. Similarly, it goes in this case, we have 3 rows and 2 columns. We have 1 row and 3 columns. So order of a matrix is always equal to number of rows into number of columns. We'll be using it in addition and multiplication of matrices. Okay, after this, what we have is a square matrix. Okay, a square matrix would be if number of rows and columns are equal, we can say that this is a square matrix. So this matrix has only 1 row and only 1 column. Okay, so this is a square matrix. Similarly, we can take an example of 3, 5, 6 and 8. This is also a square matrix because in this case I have 1 row, 2 rows, 1 column and 2 columns. So this is again 2 cross 2, 2 rows and 2 columns. Suppose I have another matrix 1, 3, 5, 6, 8, 9, 2, 4 and 8. So this is known as 3 cross 3. We have 3 rows and 3 columns. It's obvious, you can see it. We have 1, 2 and 3, right? We have row 1, row 2 and row 3, and this is your column 1, this is your column 2, this is your column 3. So 3 cross 3. So in square matrix, your rows and columns would be equal. This would be kind of a square, right? Similarly, then what is a rectangle matrix? Rectangle matrix in which number of rows are not equal to number of columns. In this case, we can say that number of rows is equal to number of columns. So number of rows is equal to number of columns. So rectangular matrix would be M is not equal to N. So if number of rows is not equal to number of columns, for example, this is a matrix say 1, 3 and 5. You can see that we have 3 rows and only 1 column. So 1, 2, 3. There are 3 rows and only 1 column. So this is 3 cross 1, right? Then comes a diagonal matrix. Now a diagonal matrix would be, suppose this is a diagonal matrix in which 2, 0, 0, 0 3 5 0 0 3 0 0 0 and 8. Okay, a matrix in which elements are only on diagonal of the entries are only on diagonal is known as a diagonal matrix. Okay, so for example we have another matrix C that is equal to, you can say it 2 0 0 0 3 0 and 0 0 and 1. So you can say that these are diagonal matrix. So after diagonal matrix, what will be a scalar matrix? Scalar matrix is going to be a diagonal matrix in which all diagonal entries are same. So for example, now if I have a diagonal matrix 2 0 0 0 2 0 0 0 2, you can see that all diagonal entries are same. This is known as a scalar matrix. Suppose this is a C matrix, this is 3 0 0 0 3 0 0 0 and 3. So this is also known as a scalar matrix. After scalar matrix, we discuss about identity matrix. Okay, so when we talk about identity matrix, this is basically a matrix, a scalar matrix if its entries becomes 1 1 0 0 1. This will be very important matrix in which we will be discussing in multiplication as well. So this is identity matrix, this is 2 cross 2, we have 2 rows and 2 columns. Similarly, identity matrix can be 1 0 0 0 1 0 0 0 1, right? So identity matrix, it will be represented as I and it will be extensively used in this chapter, so you must prepare it really well. Okay, after identity matrix, scalar matrix and diagonal matrix, I hope it is clear. So far we have just discussed about matrices, what they are, then order of a matrix, its m cross n, rows becomes first and then columns, and then followed by square matrix. It is all rows and columns are equal, it makes it a square. Then it's a rectangular matrix, rows and columns are different, then it becomes a diagonal matrix. Diagonal matrix is a square matrix in which diagonal entries are there only, rest values would be 0. And a scalar matrix is a diagonal matrix in which all diagonal entries are same, that becomes a scalar matrix. And then what is identity? Identity matrix is one in which diagonal entries are 1 only. Now let's move to operations with matrices. So when it comes to operations with matrices, it is when it comes to operations, first of all it is addition of matrix. Now two matrices can be added only. You would say two matrices only if they have same order. If they have same order. So two matrices are can only be added if they have same order. For example, if we have a matrix A 2 1 3 5 plus B is a matrix 4 6 8 11, and if you want to find A plus B, that is equal to 2 1 3 5 plus 4 6 8 and 11. So two matrices can only be added. You see in this question it is 2 cross 2 and this is also 2 cross 2, right? So order of operation would be, order of two matrices is the same, 2 cross 2 and 2 cross 2. So it has to be 2 rows and 2 columns, 2 rows and 2 columns. How we are going to add it? The first entry will be added to first, so it is equal to 2 plus 4, 1 plus 6, 3 plus 8 and then 5 plus 11. So this is going to be 6 7 it's going to be 11 and it is going to be 16. So a plus b is going to be, a plus b is equal to 6, 7, 11 and 6. This is basically, this is how we are going to add these two matrices. Similarly, it goes for subtraction. So for subtraction it is, wait, for subtraction it is, yes. So next is your subtraction of two matrices. Our first check is going to be when we have these two matrices in which their order is same. So you can say first matrix is also 2 cross 2, the second matrix is also 2 cross 2. We have 2 rows and 2 columns, 2 rows and 2 columns, so it's 2 cross 2, 2 cross 2. This is how we are going to subtract two matrices. That is going to be 2 minus 1, it's 4 minus 2, it's 3 minus 3, and then 5 minus 4. So this is your A minus B. That can be, it's going to be 1, 2, 0 and 1. So this is how we are going to subtract two matrices. So this is addition and subtraction of two matrices. Then before we move on multiplication, there is one more thing that is known as scalar multiplication. So scalar multiplication. When we talk about scalar multiplication, suppose if I have a matrix A as A, B, C and D, and I need to multiply a scalar with the matrix A, that is known as K times A, B, C and D. This constant is going to be multiplied with every single entry, okay? So it's going to be KA, KB, KC and K times D, right? It's going to be K times A, K times B, K times C and K times D. Then after this, for example, we have a matrix A, let it be 2, 1, 3 and 5, right? And if they ask you to multiply maybe 5A, so that's going to be 5 times 2, 1, 3 and 5, that makes it 10, 5, 15 and 25. So this will be 5A, that is known as 10, 5, 15 and 25. Okay guys, after this we need to cover a short form of inverse of a matrix. This is a very important topic as far as assessment is concerned. So we start with a determinant, okay? Okay, next is inverse of a matrix, and it is basically if we have a matrix, then we can find its inverse. But first we need to find out what would be determinant and a singular and non-singular matrix. So for example, we have a matrix A as A, B, C and D, and its determinant is going to be A, B, C and D. What you're going to do is you're going to multiply it with this A, D, and then you're going to subtract product of B and C. For example, if I have a matrix A, 2, 1, 3 and 6 for example, then determinant of A is going to be 2, 1, 3 and 6, that is going to be 2 into 6 minus 1 into 3, that is going to be 12 minus 3, that is equal to 9. Now this is a number, a scalar that is representing determinant of function. Now there are two definitions for related to this. One is singular and second one is non-singular. Okay, such matrices in which determinant becomes 0 is known as a singular matrix. Okay, for example, we have a matrix A, 2, 3, 1 and 6. Okay, if I take its determinant, it's going to be 2 into 3 minus 1 into 6, that is equal to 6 minus 6, that is equal to 0. So a singular matrix would be one in which determinant is going to be 0. Non-singular matrix, a matrix in which or determinant is not equal to 0. It can be positive or it can be negative. We have a matrix A, 1, 3, 5 and 8. So that makes it 1 into 8 minus 3 into 5, that will be equal to 8 minus 15, that is equal to minus 7. So either it is positive or it's negative. This is how it works. So these are very important definition, and usually from this chapter they might ask you related to this concept that what is a singular matrix. So they could give you a matrix and if it is a singular matrix or not. Second thing what we should know in this chapter is adjoint of a matrix. Okay, so if A is a matrix, maybe A, B, C and D, so its adjoint is going to be, adjoint of A is going to be, you're going to replace first and last A and D, and you're going to change signs of second and third entry. For example, if I have a matrix A 2, 3, 5, maybe 6, then adjoint of A is going to be 6, 2, minus 3 and minus 5, right? I hope it's clear. It's very basic and easy concept. Next comes inverse of a matrix. Now, in order to find inverse of a matrix, there is only one condition you should know. What is the condition for this? And its condition is it must be a non-singular matrix. Must be a non-singular matrix. Non-singular matrix, right? So for example, if I have a matrix, say 2, 1, 3 and 5 maybe, so its inverse is always equal to 1 divided by A mod into adjoint of A. This is the formula, you should memorize it. A inverse is always equal to 1 over A mod into adjoint of A. So for example, A mod in this case is going to be 2, 1, 3 and 5, that is equal to, it's 10 minus 2 into 5, 10 minus 3 ones are 3, that is equal to 7. So your A mod is equal to 7, and your adjoint is going to be, adjoint of A is equal to, you're going to change position of first and last, and you're going to change sign of first and the second and third, sorry. So your inverse is ready, and inverse is going to be 1 over A mod into adjoint of A, that is equal to 1 divided by 7 into what is adjoint, that is equal to 5 minus 1 minus 3 and 2. You can leave your answer here, and you can further, if you want to multiply this 1 by 7 inside the bracket, yes you can. Okay. Okay guys, after this the next thing is transpose of a matrix. Okay, so what we are going to discuss now is a matrix A. So what is A transpose? This is something that they usually ask in NET examination. So if A transpose is that is obtained by simply changing its rows So A transpose would be simply you change your rows with columns. So for example, A is a matrix 2, 1, 3 and 5. Then A transpose is going to be, it's 2, 1, 3 and 5, right? So this is A transpose, that is equal to 2, 3, 1 and 5. So you have simply replaced it with this, okay? Acha. Next very important concept is skew matrix. So a matrix is known as skew if A transpose becomes equal to A. There will be some cases in which transpose of a matrix will become to equal to A. This is known as skew symmetric. And then skew symmetric matrix is a matrix in which A transpose becomes equal to minus A. Okay, so you take a transpose, it becomes equal to A. This is known as a transpose of a matrix. And if you take transpose and it becomes minus times A, that is known as skew symmetric. Okay, so I'll see you in my next video. So far We have completed matrices, and in my next video we are going to discuss different questions from past papers or past practice sessions from which you'll be having issues. Okay, thank you.